start chapter 4. Chapter 4 is about probability. Probability, chapter 4. Okay, what is probability? Probability is nothing but a chance. It's a chance that something happens. Probability is measured between 0 and 1. 0 means it will not happen, 1, it will happen. So you cannot say you have a probability of 30%. This is not right. You have to say 0.3, for example. Now, experiment. What is an experiment? An experiment is a process that generates outcomes. These outcomes are called sample points. And the whole group of all possible sample points is called the sample space. Good. Now, these outcomes or sample points have some kind of probability to happen. This probability cannot be less than 0 or greater than 1. So the probability has to be of any event less than 0, between 0 and 1. 0 less or equal than probability, less or equal than 1. Okay, and if I add all the probabilities of all the sample points, the summation of all the probabilities has to be equal to 1. For example, we have a coin, a normal coin. If we toss a coin, we have two possible outcomes, head and tail. These are the sample points, and head and tail both is the sample space. The probability of head is equal to 0.5, and the probability of tail is equal to 0.5. If I add this number, is equal to 1. Another example is rolling a die. Okay? What are the possible sample points? 1, 2, 3, 4, 5, and 6. The probability of 1 is equal to 1 over 6. The probability of 2 is equal to 1 over 6, and so on. The probability of 6 is equal to 1 over 6, and if I add all these probabilities of all the possible sample points, that has to be equal to 1. Okay? Now, sometimes it's not easy to find out how many outcomes an experiment may have. That's why we need these counting rules. Counting rules, we have 3 possible alternatives. When we have counting rules, when we have multi-step experiment, so it's an experiment that has multiple steps, and in each one of the steps you may have different number of outcomes that come out from these steps. Let's say that you have N1 possible outcomes for the first step, N2 possible outcomes in step 2, and so on, N3 and N4. What are the total possible outcomes that we may have in these multi-step experiments? The number of outcomes could be N1 times N2 times N3 times N4. Okay? Now, let's go to combination and permutations. What is that? We have a big number of elements and objects, capital N, and from those N objects we're going to get N lowercase n objects. And we want to know how many possible outcomes we may have doing this. Now, if the order is not important, we call it combination. The order of these objects that we are going to get from these capital N objects, the order is not important. And the way that we're going to do it is C n, lower n, and capital N, and that is equal to n, capital N, n. We don't have a division sign in here, it's just n, and that is equal to capital N factorial divided by n factorial times n minus n factorial. What is factorial? Factorial is nothing but the number times 1 minus until going to the 1. And by definition, 0 factorial is equal to 1. In your calculator, you can find that in NCR. This is a combination, and you can get that without doing all these factorials. Now, the other thing is permutations. It's very similar to combinations, but in permutations, the order is important. So it means that AB is not equal to BA. Okay? When the order is important, we use the permutation, and we are going to use this terminology. P and N is equal to n factorial times n, and those is equal to n factorial divided by n minus n factorial. And again, by definition, 0 factorial is equal to 1, and you can find this in your calculator in what? NPR. NPR. And I have my calculator with me, and my calculator can do it, and it's just a very cheap calculator, so your calculator can do it much better than that. And find out how to do it. Assigning probabilities. Now that we know how many possible outcomes we have in the experiments, we may assign probabilities. We have three, okay, before doing that. In order to assign probabilities, we need to know that probabilities are between 0 and 1. And the sum of all the probabilities has to be equal to 1. That's a rule. That's a rule because 1 is the sum of all the possible events. Now, we have the classical method in which the probabilities are assigned depending on or assuming that each one of the outcomes has the same probability. Okay? For example, the coin, the head and the tail both have the same probability because the chance to get the head and the tail are exactly the same. Relative frequency is when we use historical data and we say, well, how many times that particular outcome happened? And depending on that, we assign probabilities. Let's say that 30% of the time these outcomes happen, so that the probability for that particular outcome would be 0.3. And the other is the subjective way in which you don't have any data available, so you're going to use very subjective method or a gut feeling. I would say that I'm going to pass this class and the probability is 0.9. That's it. I mean, you don't have any evidence, but you have to trust your feeling. Okay, let's keep going. Events and probabilities. What is an event? An event is a number of sample points that form that event. It's a set of sample points. And the probability of the event is equal to the summation of all the probability of each one of the outcome. Now, we have, this is the Venn diagram, and we have the event A. Okay? What is not A is called a complement. And you can see this is the sample space, and all the sample space has to be equal to 1. So the probability of A plus the probability of A complement has to be equal to 1. Now, let's say that we have two events, A and B. Events A and B. If we draw, this is the sample, sample space, we have an event A and event B. A and B. Okay? We have what is called union. A union B are all the elements that are in A or in B or in both. If we want to draw it, I'm going to say that A union B is this one. Now, we have the same two events, A and B, and we have what is called the intersection, A intersection B. A intersection B are all the sample points that are in A and B at the same time. If I want to draw it, this is A intersection B. Good. There is one law that is called the addition law. The addition law that says that the probability of A union B is equal to probability of A plus the probability of B minus the probability of A intersection B. Okay? Why we have to erase this probability of A intersection B? Because if we don't do it, we are going to count it twice. Now, we have what is called the mutually exclusive events. Let's draw the sample, the space, and we have A and B, and the only way that we have mutually exclusive events is that we don't have any points that belongs to both at the same time. So that the probability of A intersection B is equal to 0. That is the definition of mutually exclusive events, such that in mutually exclusive events, since this is equal to 0, the probability of A union B is probability of A plus the probability of B. That's it.